Hey everybody, welcome to Chapter 7, Section 7, the final section of Chapter 7. Here we're going to talk about modeling with exponential and logarithmic functions, meaning I'm going to give you some data and you're going to determine if it's an exponential function or a logarithmic function, or you're going to determine the exact values that make up the function, so you're going to create the function, in other words. So this first section, kind of relating it back to what we've done earlier, I give you a table. You're going to classify it. It could be linear, quadratic, cubic, quartic, or exponential. So in the past, we've covered this. The first difference, second difference, third difference, fourth difference, all that stuff. So that's by subtracting, doing the one in front of it minus 1 behind it. So like 1 minus 3, 3 minus 9, 9 minus 27, 27 minus 81, 81 minus 243. If it's exponential, it'll be multiplying. So you want to be multiplying by a common value. So if you're trying to figure that out, you'd be dividing 1 divided by 3, 3 over 9, 9 over 27, 27 over 81, 81 over 243. See, so it would go like that. So to save yourself some time, it would help to, kind of know your times tables a bit, I guess. Do a little bit of mental math. I can tell that this one is going to be exponential because it does look like it's multiplying or dividing. And this one is kind of jumping around. It looks like it's adding or subtracting by something, some sort of common difference somewhere in there, okay? But I know like 3 times 9 is 3 times 3 is 9, and 9 times 3 is 27, and 27 times 3 is 81. So I can tell that this one's multiplying. So how would you figure it out? If you couldn't tell, like I said, go backwards and divide. In other words, do the one in front, 81 over 243. Do 27 over 81. Do 9 over 27. 3 over 9, and 1 over 3. And guess what? They all equal 1 over 3. So what's the common multiple? 1 over 3. So if they have a common multiple of 1 over 3, it's an exponential function. And so for this section, that's all I'm asking is tell me if it's exponential or linear, quadratic, cubic, or quartic, or whatever. And then I might ask you what was the common multiple, and you'd say it's 1/3. Let's do the next example. So here you can, I mentioned it before, you can see that it's not really, it doesn't look like it's multiplying by a number. If it is, it's somewhere decimal. So go backwards and subtract. What is 5 minus 13? That's negative 8. What is 13 minus 5? That's positive 8. What's 37 minus 13? That's 24. What's 77 minus 37? That's 40. What's 133 minus 77? That's 56. So that's the first difference. So now what's 8 minus negative 8? That's 16. What's 24 minus 8? That's 16. 40 minus 24 is 16. 56 minus 40 is 16. The second difference is all the same. If the second difference is the same, it must be quadratic. Okay, so that's what I'll write for this one. And that'll wrap it up for this first section here. The next section, I give you 2 points, and you're going to write an exponential function that goes through those 2 points. And you'll use this function, y equals a times b to the x. That's what they'll look like. So it's kind of I don't know, maybe a unique process. I don't know. I'd write small. It's just kind of a lot of work. It's always what math students want to hear. But here you have y equals a times b to the power of x. All right. So I'm given 2 points. Remember, these are each x comma y. So they have an x value and a y value. You're gonna make 2 functions. You're gonna plug in your x and y, but you're gonna plug them both in. And obviously you can't plug them both into the same function. So what I mean is the first one will say 6 equals a times b to the power of 1. And then, so I can't plug in 3 and 54 at the same time with the one with the 6 and the 1. I'm going to write another equation, and it's going to say 54 equals a times b to the third. So once you plug in your 2 points, you have like your two equations. Solve one equation for a, and then plug that in. So if I'm going to solve for a on this one, I just need to divide by b, since b to the first power is just b. So it's kind of like physics, where you're solving for a letter, like it'll be like force equals mass times acceleration, solve for acceleration. That's basically what's going on here. So we're not getting a value for a just yet. We just know that a is going to equal whatever 6 divided by b is. So I'm just going to plug that in right there. So I have 54 equals 6 over b times b to the third. All right, so b to the third divided by b is just b squared. So this just makes 54 equals 6b squared. Okay, and then I can divide by 6 to both sides. 54 over 6 is 9. If 9 equals b squared, then you must square root both sides. And the square root of 9 is 3. So I know b equals 3. So once you figured out b, you have this little equation for a right there. And a equals 6 divided by b. So 6 divided by 3 is 2. So now I found a. So I just need to write my final function answer. Well, we said it would be a times b to the power of x. So a is 2, b is 3. So it's going to say 2 times 3 to the power of x. And that would be my final answer. So that's what I mean. It's a little bit of work, but nothing too bad, I would hope. So let's do one more example of this, but the answer won't be as nice and pretty, where it's just whole numbers. We'll have decimals, and it still will be the exact same process, though. Okay, so here are my 2 points. So we're going to plug it into y equals a times b to the power of x. 223 is my first xy, 6, 105 is my second xy. So I'm going to say 23 equals a times b squared. And then I'll say 105 equals a times b to the 6th power. And let's just solve the one on the left for a. So that means we just divide by b squared. So a is whatever 23 over b squared will be. Okay, so take that, plug it into the other a. And so 105 equals 23 over b squared times b to the 6th. So since you're multiplying times b to the 6th, that's like it's on top. It's like it says 23b to the 6th over b squared. So if you have the 6th power on top and the 2nd power on bottom, subtract the powers, you get power 4. So 105 equals 23 to the power times b to the power 4. So I'll divide by 23. 105 over 23 doesn't make a nice number, so I will keep it as a fraction. And so I get 105 over 23 is equal to b to the 4th. So you know, to get rid of a 4th power, you take the 4th root. So I'll type this into my calculator, and then I'll approximate that value for b. Rounding to 2 decimal places, I get about 1.46, okay? And so what I like to do is I will take this and I'll plug it into a. And instead of typing in 1.46, I'll hit 23 divided by, and I'll hit the control negative on the calculator. I can't show you what I mean, but if you know how to do the answer on the TI Inspire, I find a lot of students don't know how to do that. It pulls up the previous answer. So control negative, and it says A and S in little yellow on the screen. But I'm doing 23 divided by 1.46, the unrounded one, and it's squared. So I guess I'll write it in parentheses down here. And that's going to get me about 10.76. So that's my A value. All right. So my final answer here would just be y equals 10.76 times 1.46 to the power of x, and that's that, okay? Okay, so this next part is just showing you how to do it in the graphing calculator. And so obviously I can't show you the graphing calculator from this screen, and I don't have any editing software. So just look out for a link to calculator help for this in the description. Okay, but these are all the steps that you need to do when you're plugging it in to run an exponential regression. And again, you could just look to see if it's multiplying by a common multiple, but this one, it just looks kind of random. So if you were doing it by hand, you wouldn't find a common multiple, you wouldn't find a common difference. But fortunately, I'm telling you this one's exponential, and I'm telling you this one's logarithmic. You can see that the steps are basically the same, except the last thing. You're going to go to Menu, Analyze Regression, Show Exponential. This one, Menu, Analyze Regression, Show Logarithmic. Okay, so when you're doing this, I'm just going to give you the answers, and like I said, I'll have a separate video doing these, showing you the calculator screen and everything. But rounding to 2 decimal places, I get 8.46 times 1.42 to the power of x. So if you have a calculator at home and you're following along, hopefully you get this too. Otherwise, one of us made a mistake, and I think it's you. I'll laugh at my bad joke. But the second one will say a 0.86, and then it'll say plus negative 6.45, so I'll just change that to minus. And then it says ln x, all right? And those logarithmic functions, I believe, they're always going to give you ln instead of log, or log base 10, or log base e, I mean. So that being said, that's going to wrap up the notes. Thank you for watching. Goodbye, everyone.